Hello and good evening, CTS265, Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is the Cisco Networking Academy CCNP route course for version 7. And this evening's video tutorial is going to be the answer to the challenge question that we had a couple of weeks ago, where I put out for an additional challenge for some of the students to take a look at Lab 2-1 and to try to figure out what would happen if we change the encapsulation on the interfaces that we see here, right? All these serial interfaces, and each router has two serial interfaces, 000 and 010. What would happen if we were to change the encapsulation to PPP, or the point-to-point protocol, on all of those interfaces? Why does it break equal cost load balancing with EIGRP? Well, let's go ahead and take a look here. And you can see right now I've got everything configured. I'm on step 4. If you're following along in the Networking Academy lab, it's going to be page 8 of 26 at the bottom, where if I were to say trace 10.1.102.1, what we're going to see here is, again, we've configured everything the way the lab has asked right up to this point. And so we're going to see equal cost load balancing here, where traffic being generated from router 3 is going to equally balance itself across the 10.1.203 link and the 10.1.103 link. And so here we see there's the 10.1.103.1 and there's the 10.1.203.2. And now it'll go back to the 10.1.103.1, and if we run this again as soon as it finishes, what you're going to see is it's going to pick right back up in the order where it left off, which is it'll be 10.1.203.2 will be next, and then 103.1, and then 203.2 to end up our trace, proving that equal cost load balancing is in fact working. And again, this is with HDLC, the Cisco default, as the encapsulation protocol on the serial interfaces. And so we'll let this finish up here with the 203.2. And the other way we can tell that we've got equal cost load balancing is if I were to say show IP route over to the 10.1.102.1, we can clearly see here when we look at the traffic share, right? The traffic share count is 1, and the traffic share count here is 1. So our ratio is 1 to 1. In other words, it is equal, right? Equal cost load balancing. We can also see that the next path to be used, as indicated by the asterisk here, would be the 10.1.103.1. And we know that to be true because the last path used was the 10.1.203.2. So this guy would be next right here, 10.1.103.1. And again, we have a 1-to-1 traffic share count. So everything looks good. So let's take a look at the routing table, because we're going to need this for comparison. So show IP route. And so this is what the routing table looks like right now. Just as we would expect, we have an EIGRP route here for the 10.1.102.0/29, and I have two successors here. So two equal cost successors that have the same administrative distance because it's EIGRP, and they've got the same computed distance because they're an equal distance away from this successor route, the 10.1.102.0. And everything works like it should. So let's see what happens. I'm actually going to go ahead and say debug PPP, and we want to debug PPP. And let's see, not so much packet. Let's debug PPP negotiations, what we're going to want to see. All right, so I'm going to turn PPP debugging on there, and we're going to go ahead and go into global config mode, interface serial 00. I'm going to say Encap PPP. We're going to go into interface serial 010 and say Encap PPP, and we're going to see what happens here. Now, PPP is not on any of the other routers, so you can see we've got the network control protocol and the link control protocol. And right now, the link control protocol is trying to negotiate with the other side. So let's go ahead and get on router 2, and let's finish this up. And actually, we'll do router 1 first here. So we'll go to global config from privilege exec, and we'll go into int serial 000, and I'll say encap PPP, and then we'll go into int serial 010 and say encap PPP, and then we'll come here to router 2 and go into global config interface serial 000 encap PPP, and interface serial 010 encap PPP. All right, so we've got the point-to-point protocol on. You can see our adjacencies have come back on both of the routers there. And if I say show IP EIGRP neighbors, you can see I've got both of my neighbors back. Let's do it here. Show IP EIGRP neighbors. I've got both of my neighbors here, and now we'll come back to, excuse me, we'll go ahead and we'll come back to router 3. And this was the router where we went ahead and configured the debug. And so let's take a look at this debug output here. And this was kind of the hint that was provided to a couple of students that were pursuing the answer. And it comes right down to, remember we talked about the IP control protocol and what happens after the IP control protocol runs. And so you can see here we've got this notification that's telling us route not installed to the 10.1.203.2, right? So we get this note telling us that the route hasn't been installed. We can see up here that the address negotiation with the IP control protocol is working. We got the configuration acknowledgement. We're receiving this configuration request, and what does it say? Added to neighbor route AVL tree address 10.1.203.2. Okay, and then IPCP IP control protocol comes up and says route not installed, right? So let's take a look. Let's clear the screen here. Let's go ahead and take a look now and see what the routing table looks like. So we'll say do show IP route, and what do we see? Well, it clearly appears that we have some additional routes. So here is the EIGRP route that we have for the equal cost multipathing, which is a /29, right? Because it's for this transit network right here between, and let me bring that back a little bit, between router 1 and router 2. However, if we look, we have something new here, which got picked up in EIGRP. So it says 10.1.102.1. Now this is the address that we were tracing to, and take a look at what the next hop is. It's 10.1.203.2. So we now have this new EIGRP route. Let me scroll back up here. Let's look at the routing table before. And we've got quite a bit of output there. And there was no EIGRP route here for 10.1.102.1. A /32 did not exist. So if we come back down, you can clearly see that we have this 10.1.102.1. Now, how did this route get installed? Well, it comes down. You'll notice, remember, it said it was trying to install a route to 10.1.203.2 in our debug output up here. Remember this? It said added to neighbor route AVL tree topology ID 0, the 10.1.203.2, and then it says route not installed. However, we have this route that now is auto-magically installed for us. And what's the difference between this route and the route over which we would like to do the equal cost multipathing? Well, if you look here, you can clearly see that we have a /32 and a /29. So all things being equal, which path is the traffic going to go across? Absolutely. The number one criteria is longest match, and a /32 is a longer match than a /29. In fact, we know right now that when we go to trace, it's going to go out the 10.1.203.2. So that traffic is going to go out the 10.1 I shouldn't say out the 10.1.203.2. It's going to go out the 10.1.203 serial 000 interface here on router 3, and this is the .2 right here. So it's going to make its next hop to the successor 10.1.203.2, because we've now installed this peer neighbor route that got picked up in the EIGRP network statement. Because on this router, if I were to say do show run, pipe it to section EIGRP, you can see we did just a network 0000, right? So let's go ahead and let's refine that. Let's go into the router EIGRP1, and we're going to say no network 0.0.0.0, and I'm going to say network, and we're going to make it a little more granular here. 10.1.203, oops, sorry, 203.0, and the /29 is going to be 0.0.0.7. So that should bring the adjacency back with router 3. And then let's do that same thing over on 102. And that should bring my adjacency back with 10.1.102.0. Should bring my adjacency back with router 1. So if I were to say do show IP EIGRP neighbors, you can see right now we only have one neighborship. And let's make sure that's a /29. Do show run int serial 000, and that is, oh sorry, wrong interface there. Are those backwards? 10.1.203, those are backwards it looks like. So 0.10 is the 10.1, oh I'm sorry, I'm on router 3, my apologies. So let's pull that back up. I'm on router 3, so we'll say Control A. No, so yeah, I wanted to have 10.1.103. I was looking at the wrong network statement there. All right, so now that I've fine-tuned it down, right, and I'm no longer just saying, hey, run EIGRP on all interfaces, now let's take a look at the routing table. So I'll say do show IP route, and you can see that we still have this route that we're learning in EIGRP from router 2, right? And this is router 2 right here, so I'll make a little note here. So they say this is router 2. Drawing with the mouse, it's a little more difficult. So that's router 2 right up there. So that's who we're learning the route from. And the reason is that we're going to have, it's installing a peer neighbor route. So let's check out and see show run, and let's pipe it to section EIGRP. Let's see if we use the network statement. So we did. We threw it on all of the interfaces. So let's do the same thing here. Let's go in and make sure that only the interfaces that should be running EIGRP are doing so. And let's see here. So let's go and say router EIGRP1, no network 10.0.0.0. And we're going to say network 10.1.203.0.0.0.7. And then network 10.1.102.0.0.0.7. And then we get our adjacency back. Now let's check over here and see if I say do show IP route, do we still have that route? And we do. We still have the 10.1.102.1. And the reason is that PPP is going to install a peer neighbor route. So here on router 2, if I said do show IP route, so we end up with a directly connected route, the 10.1.102.1, between router 2 and router 1. And so if we look over here at our drawing, right, so between these two routers, you get this directly connected 10.1.102.1 via serial 010 route, which is a peer neighbor route. Now it shows up on router 3 in EIGRP because we had network statements that cover that here, because we're running EIGRP on this interface, and so it installs a peer neighbor route. So let's see what happens and we'll say Control C. So let's see what happens over on router 1 if we were to say show IP route. So we should have on router 1 a peer neighbor route for the 10.1, and where is it at? The 10.1.102.1. So here's the local route. There is the /29 network, right? And so we've installed that peer neighbor route over on router 2 that shows it's directly connected to router 1. So if I come back over to router 2, if we were to turn off PPP between router 2 and router 1, so if I were to say, let's say do show run interface serial 000, and we want the other interface, so interface serial 010, and said no encap PPP, and then went over to router 1 and said show run int serial 000, which is the 10.1.102.1, and I go into this interface, let's say global config, and say interface serial 000, no encap PPP. I'll come back to router 2, the adjacency is back up, and I say do show IP route. Do I have that peer neighbor route anymore to the 10.1.102.1? You can see it's gone. So the peer neighbor route is no longer there. If I come over to router 3, who's still running PPP as his encap between router 1 and router 2, now what do we see? So there is no peer neighbor route that's being picked up here anymore because we've terminated that, the PPP encapsulation between router 1 and router 2. So now what's going to happen if I say do trace, and actually before we do that, let's say do show IP route 10.1.102.1. And you can see it shows that we're going to be doing equal cost load balancing. The first one that we're going to hit is going to be the 10.1.103.1 because he should receive, the next packet. So with that PPP encapsulation off between router 2 and router 1, we no longer have a peer neighbor route being installed on router 2. And there you go, the 10.1.103.1, and then it's going to hit the 203.2, and then the 103.1, and then we'll do that show IP route command again, and we'll see that the asterisk will be next to 10.1.203.2 because that path would be the next in line. And actually it's showing the 103.1 is going to be the next path in line. I was anticipating it would be next to the 203.2. So again, we now have the equal cost load balancing working again because there's no peer neighbor route installed here. So if I were to debug here and say debug PPP and negotiation, right? And go into global config and go back into interface serial, and let's make sure we get this right, do show run interface serial 010, and that's the interface. So if I go into interface serial 010 and I say encap PPP, and then I come over to router 1 and I say encap PPP, let's go back to router 2 now, and let's see when IPCP kicks in, if we get the peer neighbor route installed, and we do. And so you can see right here, IPCP comes up and says install local route to 10.1.102.1. And the fact that this peer neighbor route gets installed and it's a /32, it gets picked up, and you can see right here, install route to 10.1.102.1. What ends up happening is that peer neighbor route gets installed and it gets picked up by these EIGRP statements. On this router here, we've got a network statement, and this one here, that are matching a /29, and this would fall in that range. And so therefore, the peer neighbor route gets installed, right? You can see we've got that right there. If I come over to router 3 and I say do show IP route now, it's gone. The equal cost load balancing is now gone. And if I say do show IP route, it shows that the equal cost load balancing is there, but it's not going to be used because we're picking up this peer neighbor route that's advertised via EIGRP, originated from router 2, and that is why, again, remember, all things being equal, how is OSPF, and I'm sorry, I grabbed the wrong one, I meant this one right here, the 10.1.102.1. So, but again, the 10.1.102.1 is via 10.1.203.2, so it's the successor is router 2, the successor route that we're tracing to now has a /32 match, and it's going to be compared to a /29 match. And who's going to win? Because take a look, all the costs are equal. The administrative distance is the same. And again, the #1 match criteria for iOS is longest match. So we end up with this new route in the routing table, which is generated from the peer host route that is learned here on, or that is created here on router 2 because of PPP, right? It installs that route for us. So let me clear the screen. And so now the second part of the question was, well, how do I fix this? And this is where, if you got to the peer neighbor part and you saw that the route was being installed, you could simply say, so we'll say router, or actually not on the interface, I'm sorry. We'll say no peer neighbor route, and I'll hit enter. And so then I'll come over here to router 1, and I'll say no peer neighbor route, and enter. So when we come back to router 2, if I say do show IP route, do we have a route, excuse me, a peer neighbor route installed here? We do not. Remember, if I roll back up after we did the change, excuse me. So we've got the directly connected route, right, for the 10.1.102.1 from the perspective of router 2. But again, there is no peer neighbor route here. So if I come over to router 3 and say do show IP route, and it's actually still showing the peer neighbor route in there. Hold on, let me actually clear here. So let's say do clear IP EIGRP neighbor soft. So we'll do a soft reconfig, and let's see if that pulls it out. So we'll say do show IP route again. And no, we're still sitting on that peer neighbor route. Oh, let me make sure that it doesn't need to be. It should not need to be done on. Yeah, it should not need to be done on all interfaces. Did I not do it on the right interfaces? Let me see here. So let's say do show run interface serial 000, and that's where we have the no peer neighbor route. And let's go to interface serial 010 and say no peer neighbor route. And I'll do it on both of the interfaces here. Interface serial 000, no peer neighbor route. Do show run interface serial 010, and we've got the no peer neighbor route. And let's go ahead and we'll put it here on interface serial 000 and no peer neighbor route, and interface serial 010 no peer neighbor route. And let's come back with a do show IP route, and that peer neighbor route is still in there. Do clear IP EIGRP neighbor. So the no peer neighbor route should pull that out for me. And what we may need to do show IP route, we may need to take the interface down. That may sit in there. Yeah, let's go ahead on router 2. I'm going to go into interface serial 000 and say shut, and then no shut, and then interface serial 010 and say shut, and then no shut. And it might be that I'm just not being patient enough with the PPP protocol. And there we go. So that was really what it was. I don't think I was being patient enough with PPP to letting it update. I applied the command, maybe order of operations issue, where I put in there no peer neighbor route after PPP was already up. And so taking PPP, taking the interface down and then bringing the interface back up has removed that peer neighbor route from the routing table. And so now we have PPP as our encapsulation, and now let's do a do trace to 102.1, and let's see, is equal cost load balancing in effect? Excuse me, so we would expect it's going to go to 10.1.2032 or 10.1.103.1, and then it'll just simply round robin between, and there we go. There's our 10.1.103.1, so we should see 203.2 next, and we've got that peer neighbor route is out of there, and there we go. And so this actually solves the challenge question. So again, to recap, when we enable PPP, we get a peer neighbor route installed, and it's getting installed on router 2. And then what's happening is that route is a /32, and so it's being advertised by EIGRP as a /32, which is a longer match than the /29 EIGRP route that we already have in the routing table, which is what we were using to do the equal cost load balancing. But as soon as that /32 showed up in here for the exact same 10.1.102.1, then that is the route we're going to match, and it was matching out the 10.1.2032 because that's where it was being learned from the successor router 2. Then in order to fix that, we had to apply the no peer neighbor route, and then take the interface down and then bring the interface back up. And again, that may have taken place naturally, and I probably just wasn't being patient enough with PPP, but I went ahead and forced it by shutting the interface down and bringing the interface back up. Now here's something that's very, very interesting. And remember, PPP was a technology used back in the dial-up days. So, excuse me. So, what you can actually do with PPP, and this is because of the installation of the peer neighbor route. So if I were to say do show run interface serial 010, and that's the interface that I want. So if I were to go into interface serial 010 and say peer neighbor route, and then I were to say IP address 209.165.200.1, and actually we'll do 200.2 because it's router 2, and we'll make it a /24. And then I'm going to come over here to router 1, and I'm going to say do show run int serial 000. I'm going to say peer neighbor route, which is the default, and I'm going to say IP address 192.168. We'll say 11.1, and I'll make this a we'll make it a 248. So we'll make it a /29. So I've got two connections, excuse me, between these routers, and the interface just came back up, right? And so if I were to say do show IP route with PPP and that peer neighbor route getting installed, take a look at what just happened. So this is from router 2. So I have a directly connected route to the 209.165.2, which is on the serial 010 interface of the next hop, right? Because this is on router 1. So I have a directly connected network to 209.165.2.0. Well, what if I try to ping that? What if I were to say and we want to get that off of there. So if I were to say do ping 209.165.200.2, how is that possible? Let's go over to router 2 and say do show IP route. And I bet you I've got a directly connected route, and it looks like it's EIGR. No, it shouldn't be EIGRP. What did I make it? A 192.168? Yeah, why? Oh, is that because on router 1, hold on, I think router 1 is do show run section EIGRP. Yeah, I've got the, let's fix this network statement here. So let's say router EIGRP, whoops, EIGRP1. And if I were to say no network, and see, this is one of those use cases where you want to control the advertisement. So I'm going to say 10.1.103.0.0.0.7. So that'll bring my adjacency back up with router 3. 10.1.103.0. So that's correct. And then on router 1, so let's do this. What would happen if I were to say network 192.168. What did I use? .11.0, 0.0.0.7, because we did that as a 248. So now let's come back over here to router 2, and let's go into router EIGRP1, and let's say network 209.165.200.0, 0.0.0.255. So if I can ping back and forth between these networks, should I be able to get an adjacency established? No. But do I have connectivity? If I were to say do ping, and actually let me do this real quick here. Let's say do clear IP EIGRP neighbor. Do show run interface serial 000. All right, and then do show run interface serial 0. Oh, did I change the wrong interface? Serial 010. I think I changed the wrong interface. So let me go into interface serial 010 here on router 1 and say IP address is going to be 10.1.103.1, and that's going to be 248. So my EIGRP adjacency should come back here with router 3, do show run section EIGRP. Yeah, we've got the 10.1.103.0. So now let me go into interface serial 000, and we're going to say peer neighbor route. And here is where we're going to change the IP address to 192.168.11.0, subnet mask. And we'll do one, we'll make it a /24, or actually we'll stick with that that /29. Okay, so we've got our not common subnet on serial 000 to the neighbor 10.1.102.2. So it says locked, not on common subnet, right? So you see these errors we're getting because between router 1 and router 2 right now, what I'm doing is the IP here is 192.168.11.1. The IP here, and this is serial 010, is 209.165.200.2. And this is a /29, and this is a /24. Now these are clearly not on the same subnet, and so you can see we're getting error messages. Excuse me, we're getting error messages, basically alerting us to that fact. So if I were to say do show IP EIGRP neighbors, you can see that we don't have any neighbors right now, because again, these guys are not on a common subnet. But if I'm on router 1 and I say do show IP route, you can see that we get a directly connected route for the 209.165.200.2. So if I were to say do ping again 209.165.200.2, I've got reachability. And how is that possible when I've got, these are two completely different subnets that are directly connected? If I come over here, we're getting that same error, not on a common subnet, do show IP route. And it doesn't look like, let me shut the interface down here real quick. Let me say shut, because again, order of operations, I had the peer route on that interface and then took it off. So then we'll say no shut. and do show run int serial 000 should have, yeah, so the peer neighbor route is the default. So the interface is going to come back up. And what we should see, do show run int serial 010. Oh, I've got the no peer neighbor route here. So interface serial 010, and I'm going to say peer neighbor route. And then we'll shut this interface down. And then say no shut. Do show IP route. And take a look at that. I get a directly connected peer neighbor route installed here on router 2 for router 1's interface. So if I were to say do ping 192.168.11.1, I've got full connectivity between those two routers. However, do show IP EIGRP neighbors. My only neighbor relationship is going to be with router 3. Again, we're going to have a problem here because these are definitely not on a common subnet. However, I've got full reachability with respect to being able to ping across that link. And so that is what the peer neighbor link was used for. And again, in the old dial-up days, it was to install, you would be able to assign IPs that were dialing in. You could assign all kinds of IPs, and PPP would simply install the peer neighbor route, and then you would have full connectivity. And that's how they were able to get around, exhausting all the IPs within a specific subnet. You would just simply say, let them install any IP out of the pool, and we'll just go ahead and install the peer neighbor route with PPP, and that would guarantee that you would have full connectivity. All right, so this is the answer to the challenge question from a couple weeks ago. This is how you would configure it. This is how you would confirm it and validate that it is a peer neighbor route. And then we took a look at how you would manipulate that peer neighbor route, change it on the interfaces, and again, shut the interface down and then bring it back up, and you would get it to be installed. Another use was on unnumbered interfaces, where you would have the PPP peer neighbor route would come into play if you had an unnumbered interface. So again, definitely interesting behavior, and I can clearly see why the lab had us use HDLC instead of PPP. All right, enjoy the rest of your weekend. I will see you on Monday.